Welcome to the Analog Design Flow video for SmartFusion. This mixed-signal design will configure one of the 32 SmartFusion ACE analog channels to monitor the voltage across the potentiometer on the SmartFusion evaluation kit board. The ACE will be configured to monitor specific voltage levels and then switch on the LEDs on the evaluation board as the voltage reaches pre-assigned threshold values of 1.0, 1.5, 2.0, and 2.5 volts. At the same time, you will be able to see the actual voltages through the hyperterminal application on the PC monitor. Save and close the MSS. To complete the hardware design, open Smart Design by clicking the Smart Design button on the Libre IDE Design Flow window. Name the Smart Design component ACE Top and click OK. The Smart Design canvas opens. Note that you can see the generated voltage monitor MSS component in the Design Explorer hierarchy window with an IP icon to the left of it, indicating that it is now an HDL component that is ready to be instantiated into the top-level design. Drag and drop the voltage monitor MSS IP component from the Design Explorer onto the Smart Design canvas. Now highlight the GPIO ports 24, 25, 26, and 27 by dragging the cursor over them and then right-click and select Promote to Top Level. It is at this level that you will assign these top-level ports to package pins by going to the toolbar, selecting Smart Design, and then Show I/O Attribute Editor View. Find the M2FGPO 24, 25, 26, and 27 ports. Go to the pin number column and assign the pins B19, B20, C19, and H17 respectively. These pins directly drive LEDs 1 through 4 on the SmartFusion evaluation kit board. Note that you can change many other I/O attributes on this page, such as I/O standard, slew rate, resistor pull, and output load. MSS pin assignments are locked, but you can edit some MSS I/O attributes in this view. Now, right-click on any of the unused parts of the Smart Design canvas and select Generate Design. This action will design rule check and convert your project into a synthesizable HDL file. Click the Libre IDE Project Manager tab. Right-click ACE Top in the Project Explorer and select Set as Root. Then on the Project Flow tab, click the Synthesis button. Simplify Pro opens. Validate the project settings and click Run. Simplify Pro completes the synthesis within a few seconds. Close Simplify Pro when done. Click the Place and Route button on the Libre IDE Project Manager Design Flow window, opening the Designer Organize Constraints dialog. Import the acetop.edn, acetop.pdc, and acetop.sdc files by clicking OK. Now, click the Flash Pro Data button to start the compile, layout, and program file generation processes. Save and click OK on the various dialogues that open through the process. With the timing-driven mode selected, layout will run several times to achieve the best timing, so it will take a few seconds to complete the process. When the Compile, Layout, and Flash Pro Data file buttons are green, the process is complete. Close Designer and click Yes to save the file. Going back to the Libre IDE Project Flow window, click the Flash Pro Programming button to program the SmartFusion AF200 device on the SmartFusion Evaluation Kit board. This tutorial already has the SmartFusion Evaluation board connected to the PC via the USB cables. The Flash Pro software interface opens. Line 1 shows that the Flash Pro programmer is connected. The SmartFusion Evaluation board has a built-in Flash Pro programmer. Click the Configure Device button and then click the Modify button in the Programming File window. Note that the AceTop FDB file and the MSS ENVM0 EFC files already are in position to be saved within a PDB programming database file. The FDB file is created by use of the SmartFusion fabric, and the EFC file is created from the SmartFusion MSS configurations. Click the Save PDB button. You are now ready to program the SmartFusion FPGA on the SmartFusion Evaluation Kit board. Click the Program button, and the FPGA hardware program will be programmed into the device. At this point, the FPGA hardware design is complete, and you are ready to implement the embedded software program using Soft Console. Close FlashPro and Libro IDE. Start Soft Console from the desktop icon or from the Start menu. Select the Workspace button, and Soft Console opens. Create a new project by clicking File, New C Project, and enter the project name as Voltage Monitor. Select Actel Cortex M3 Tools in the Tool Chain window and click Next. This opens the Select Configurations dialog. Be sure that the Debug and Release checkboxes are checked and click Finish. Next, you will import the firmware drivers that were selected to support the MSS peripherals. Right-click the project name in the Project Explorer and select Import. Expand the General tab and select the file system and click Next. Browse to the location of the SmartFusion Voltage Monitor project folder created from the Libro IDE. Open the folder, click the Firmware folder, and click OK. Expand the Firmware folder and check the CMSIS, Drivers, and Drivers Config checkboxes. Click Finish, and you will now see these folders under the Voltage Monitor project name in the Soft Console project folder. Next, you will view the main.c C code program that was pre-written and copied into this project. The C code program works with the SmartFusion hardware to monitor the voltages coming from the potentiometer, display them on the PC monitor via hyperterminal, and switch the evaluation board LEDs on or off depending on the measured voltage levels. This will be demonstrated at the end of this video. Now you have to include the MSS drivers into the project by right-clicking the project name, Properties, Settings, GNU-C Compiler Directories, and clicking the Add button. The Add Directory Path dialog opens. Click Workspace and expand the Voltage Monitor folder. Click the CMSIS folder and click OK. Then click OK in the Add Directory Path dialog. The folder now appears in the Include Paths window. Use the same method to import the drivers config, MSS ACE, MSS GPIO, and MSS UART drivers into the project. Click Apply to save, then click Miscellaneous under the new C linker. This linker script builds an executable that runs from the SmartFusion internal SRAM. In this video, the linker script was already imported into the project. Make sure that the script is as shown in the linker flag window, then click Apply and OK. Now build the Soft Console project by selecting the project name Voltage Monitor in the Project Explorer and select Clean from the project menu. Click OK on the Clean dialog. Select Open Debug dialog from the Run menu. Right-click the Actel Cortex M3 RAM target and select New. You will see the name Voltage Monitor Debug. The project is Voltage Monitor and the application is Debug Voltage Monitor. Click the Debug button and Yes on the Confirm Perspective Switch dialog. Now you are actually ready to load and run the SmartFusion embedded program. The PC has already been set up with hyperterminal for the project. With the hyperterminal in view, click the green Resume button on the Debug toolbar, and you will see the Welcome to Actel SmartFusion Voltage Monitor message on the monitor. This message comes from the SmartFusion RAM embedded program. Now, with the evaluation board potentiometer clicked all the way clockwise, press any key on the PC. You will see all zeros on the hyperterminal monitor. None of the LEDs on the evaluation board will be on. Gently turn the evaluation board potentiometer counterclockwise to turn up the voltage. Press any key on the PC, and you will see a voltage on the monitor that corresponds to the pot output voltage as measured by the SmartFusion analog input TM0. As the pot is rotated through 1.0, 1.5, 2.0, and 2.5 volts, LEDs 1, 2, 3, and 4 will turn on. You can verify the exact voltage output with the PC monitor. Rotate the potentiometer clockwise again to reduce the voltage, and notice that the LEDs switch off, coinciding with the threshold flag voltages set in the SmartFusion ACE configurator, and actual voltage is displayed on the hyperterminal.